Good morning, everyone. I'm going to start the lecture now. I'm going to start the lecture with an apology because I inadvertently clicked on week 3, lecture 2, when I really meant to click on lecture topic 3. Topic 3, of course, is occurring in week 2. In any case, after the lecture, I will relabel the cover slide on YouTube so that you can easily identify that and it's in the right place, and we'll put it in the right order in the pre-recorded lectures so you can find it more easily. What we're going to do this morning is go back and look at demand in more detail. As I said to you yesterday, elasticity of demand is quite a big deal in the way that it impacts on later topics. So it's a big area. The area of demand is fairly big anyway, and then the elasticity of demand is a big area in itself. And as we got towards the end of yesterday's lecture, I realised that I couldn't really get through it properly in the time frame yesterday. So I'm going to start today with a bit more explanation about elasticity of demand. Between yesterday and today, I've also added a few slides into the demand lecture, and I've updated those slides on Moodle. So the slides that you find on Moodle now should be the slides that I'm presenting in this presentation today. So if you want to quickly go back into Moodle and look at the latest version of those of topic 3, chapter 3, you can do that quickly as we start the lecture and find the slides that I'm using in the slide presentation. So we're starting with elasticity of demand. I will do a little bit towards the end about elasticity of supply. I'm not going to do much on it because once we get our head around elasticity of demand, elasticity of supply kind of becomes easier to do, and you'll be able to figure that out pretty easily by going through Placonomics and then doing the exercises. So let's get started on elasticity of demand. As we start elasticity of demand, of course, we'll just revise the law of demand and then get into what elasticity means and some of the implications for the firm. So I'm going to transition now to the presentation. You should see the presentation now, and so we're starting pretty much where we left off yesterday, but I'm starting with a few new slides. And so we just quickly revise the law of demand. So yesterday, of course, we did the law of demand. We did it in a fair bit of detail. And the law of demand is pretty much explained by the shape of the demand curve, where we have quantity on the bottom axis, price on the top axis, and all we need to do then with the law of demand is to say if the price is at P1 and then the price falls to P2, then that will also change the quantity. The quantity there will then rise to Q2 from from Q1 which means that as the price goes down, as there is a fall in the price, as the price falls, the quantity rises. So the relationship between the change in price and the change in quantity are inverse. So that's where we got to yesterday, right? That as one goes down, the other one goes up. So then we move to our next slide. We move to our next slide and we say, all right, so we know what the law of demand is, right? The law of demand, it's inversely related to the change in price. As price rises, the quantity demanded will fall, but then when we get into the area of elasticity, we want to know how much it will fall, or when the price falls, the quantity demanded will rise, but again, how much? So that's really what the elasticity is about. It's not about the law of demand. It's about the responsiveness. How strongly does that law of demand work and hold? So I've got two products here, and I'm going to illustrate with these two slides what we mean by elasticity. Now, we did do this yesterday, but these slides are a little bit... Yesterday, I did a drawing for you, but today we've pre-drawn the diagrams. You can see on both diagrams there is an identical price rise, right? The price goes from P1 to P2 in both cases. However, the extent of the quantity change is not the same. You can see the extent of the quantity change is not the same. The one on the right, the response, right? This is a stronger response. Right, that's a stronger response to the price rise. So if we look at the one on the right-hand side, you can see that there's a very big fall in the quantity demanded, whereas the one on the left, there is a smaller fall. So if we want to know which one we regard as the more elastic demand, well, the one on the right. The one on the right is the one with the more elastic demand. So we then move down and just define the price elasticity of demand here. We're going to define the price elasticity. So it represents the percentage change in the quantity demanded resulting from a percentage change in the price. I don't know that we necessarily need to assume it's a small change in price. We're just looking at the relative change in demand to the relative change in relative change in quantity demanded and the relative change in price. So the key word when we're looking at elasticity is the responsiveness. And we saw that in the diagram on the right, the Coca-Cola, it was far more responsive to price changes. Now, why would that be? Why would it be that the change in demand for the Coca-Cola is bigger? Maybe it's because the Coca-Cola is not a necessity product. So when the price of the Coca-Cola rises, when the price of the Coca-Cola goes up, as I'm indicating here, people figure that they can do without the Coca-Cola. Whereas the one on the left, which I'm going to circle in green, right, when this one goes up in price, people are going to most likely continue to buy that, because if they've got a terrible headache, they're not really going to worry about the difference whether the Panadol costs $3 or $4, because the product is at that point in time a necessity for them. So we have the two different products and the two different elasticities, and then we have a method of calculating that the elasticity. And this is where we got to yesterday, and I did a little diagram, a hand-drawn diagram with you yesterday, and I showed you that in the diagram on the left, the change in the quantity is smaller than the change in price. So here's the change in quantity. It's a small change in quantity, whereas the one on the right is a much bigger change in quantity, even though the change in the price in the left and the right diagram is the same size. And that's how we get our value for elasticity. This is how I'm pointing to that now, right? This is how we get our value for elasticity, is by putting the percentage change in the quantity over the percentage change in price, because we're assuming that the change in quantity was caused by the change in price. And so we use the equation that we see in front of us, so I'm going to go through a little calculation demonstration with you now. So we know that the price has changed in both cases, right? The price has changed, identical change in price, right, in both cases. However, the change in quantity, of course, is not the same. So what we're going to do now is move and substitute some numbers in here. I'll come back to the slide that we have there. So we're going to imagine in both of these cases, let's go back up. We're imagining in both of these cases now, we're going to do a numerical example. We're imagining that both of these products experience a rise in the price. So they both experience a rise in the price. It's the same rise in price, same absolute number and the same percentage. But of course, as we said, the change in the quantity will be different. So let's insert some numbers now. We're going to imagine that the price is going from I've made a mistake here, I think. Yes, it will give us the same answer, except that I've made a little error here. We're going to just imagine that the price is not rising, the price is falling for both of them. I've messed this up a bit. Let me see. Oh, yes. I've just put the wrong words in here. Let me do this. I think this will be all right. So we're going to imagine that the price is going to. We're imagining that the price is going to fall. Right? The price is going to fall. So we're going to change that. right? Price is going to fall, and the quantity is going to rise, right? The quantity is going to rise. So we've got that's going to go up. So in both cases, the price falls, right? The price falls, and in both cases, the price is going to fall from 20 to 15. So if we're looking at the percentage change in price, the percentage. Oh, I've messed this up. Let's go up here. I'll fix this. Right, I'll fix this for you. 18 and 20. I'm going to change it this way. We're going to have the price falling and the price falling. So our change in price, right? Our percentage change in price in both cases, right? The percentage change in price equals 5 on 20. So that equals 25%, right? 25%. And our percentage change in quantity, I'm going to change this number here, right? I'm going to change this number here. I'm going to make that 20, and I'm going to make this 22. 20 and 22. So in the left-hand one, right, in the left-hand one, I have the change in price equals 25, and the change in quantity is 2 on 20. So the change in price is 25, and the change in quantity is 10%. 10%, because it's gone from 20 to 22. So our change in quantity changed by 10%, and our change in price changed by 25%. So what I'm going to have here is an elasticity of 0.4. All right, 0.4. And then on the right-hand side, what is my change going to be on the right-hand side? Well, I'm going to have a change of 40, right? A change of 40 over 10. So that's going to be 400%, right? So this is a percentage change in quantity, right? The percentage change in quantity is 400%. So that's going to be 16. Right, so we're going to have a much higher change in quantity than change in price. So we can see that this is 16 is more than 1, 0.4 is less than 1, but in both cases with the elasticity, look at what's happened to the change in price. The price went down, the quantity went up, the price went down, the quantity went up. And in fact, although we have 0.4 and 16, we have a negative number and we have a negative number. So both of those numbers are actually negative because the shape of the demand curve, which I'm shading on the right-hand side, is downward sloping. So that negative sign doesn't really tell us much, except that when the price goes down, the quantity goes up, and that is just the law of demand. So although we know that the price elasticity is negative, we just ignore the sign. So I'm coming down to this slide, but this slide now is, of course, totally wrong. So I'm going to actually delete that slide, I think, or delete that slide from the presentation. All right, now, so when we think about price elasticity of demand, let's think about this. Because we're dealing with absolute numbers, right? Because we're dealing with absolute numbers, we imagine that to get our head around the idea of elasticity, there are no negative numbers, right? There's no negative numbers. So we eliminate this because when we're talking about price elasticity, we're dropping the negative sign and everything is an absolute number. And so then if we say, well, what does inelastic mean? Inelastic means anything where we go from 0 in absolute terms, 0 to 1. So what do we mean? We mean, well, 0.1, 0.8, right? Something like that. Once we get to 1, then that is unit elasticity. And any number beyond that, right? In any number beyond that, 1, 2, 2.5, 3, 16, as we did just on the previous example, in any number like that will be elastic. So that's how we measure elasticity. That's how we measure elasticity. We might do another example here. So what we've just done there is method number 2. What we've done is method number 2. If we want to measure the elasticity in the example before us here, what do we have here? We have if I have a rise in price, right? If I have a rise in price, then that is 4 on 10, right? So that is, 4 on 6, right? That's 4 on 6. So what does that give me? That gives me a 66% rise in the price, change in the price. On the other hand, what is the change in the quantity? Right? What is the change in the quantity? 2 on 7. Right? 2 on 7. So that's about 0.4, I think, right? So 2 on 7, because we're moving from 7 and we're moving on the vertical. So this is about 40%, I think, roughly. About that. So that's the change in the quantity. And so that would tell us that going between B and A, demand is inelastic, right? Going between B and A, demand is inelastic. Because why is this? Because if I have 40 on 60, I'm going to have a number that is less than 1. My measure for elasticity will be less than 1. So how did I get to the numbers here? How did I get to the numbers? I got the change in quantity over the original quantity, which was 7, and I got the change in price over the original price, which was 6. If we were to do this calculation in reverse, we would get a different answer. If we moved the price down from 10 to 6, we'd get a different answer. Our elasticity would be 1. In fact, we did that example yesterday. Okay, next. So elastic demand means that the absolute value for elasticity is greater than 1. Inelastic means it's less than 1. If it's exactly equal to 1, it means it's neither elastic nor inelastic. we're just at the point where we're in between those two. We're at the point where we're in between elastic and inelastic. So that's what we mean when we're doing what is called the first price method. We get the change, right? The change in the quantity over the first quantity, the original quantity, and we put that over the change in price over the original price. That's how we calculate our elasticities. I'll clean all this up now. All right, moving on. So that is method one. All right, that's method one. Now, what about method two? Method two, we'll come back here to our slide. Let's clean this up. Method two is called point elasticity. So method two is point elasticity. On this slide, it's actually written down as 1. All right? It's written down as 1. This is a very untidy slide. I'm going to, I think I'll insert a slide here, and I'm going to write the formula more neatly for you. The printing has jumped out a little bit there. Let me just go down and I'll create a blank slide for you. Okay, so what we're doing now is what we refer to as point elasticity, right? Point elasticity. So let's think about point elasticity. Point elasticity. Point elasticity. Now look at the formula. First of all, we say point elasticity is the price of the good and the quantity over the quantity of the good multiplied by 1 over the slope of the line. Multiplied by 1 over the slope of the line. So I'm going to go back to our diagram that we saw before, and I want to talk to you first of all about what is the slope of the line. What is the slope of the line? What does that mean? So the slope of the line equals the vertical over the horizontal axes. So the slope of this line is 2. The slope of this line is 2 because the slope of the line is 20 over 10. That is the slope. So the slope of the line is 20 over 10 because the horizontal is 10 and the vertical is 20. So let's just insert that in there. Right, the slope of the line. Right, the slope of the line is 20. That's the vertical over 10, which is the horizontal. That's the slope of the line. So the slope of the line equals 2. Right, there's the slope of the line. It's 2. And I'm going to say, what is the elasticity at point A? What is the elasticity there? Well, what's the price there? The price there is 10. What's the quantity there? 5. So the price is 10, the quantity is 5. So let's work out the elasticity at point A now. The price is 10, the quantity is 5, and we have 1 over the slope, which is 2. So now we have 10 multiplied by 1 and 5 multiplied by 2, and that will give me an elasticity of 1. So if I come back to this line, the elasticity at A equals 1. But what about at B? What does it equal at B? What does it equal at B? Well, the slope is the same, but the price at B is not 10. The price at B is 6. And the quantity at B is 7. So let's go over to the next page. All right, so what is the price at B? 6. What is the quantity? 7 multiplied by 1 over the slope. The slope of the line is the same. It's the same line. So now we have 6 times 1 over 14, and that will give us a number a little bit around 0.4 something. Right, about equal to 0.4 something, right? 45, something like that. So that is less than 1. So the top one, right? The top one is unit elasticity. Point A is unit elasticity. Point B is inelastic. Right? So point A, that's unit elasticity. It's neither elastic nor inelastic. And point B is inelastic. If we nominated another point on this line, if I nominated a point up here and I called that point C, that would be elastic. We would find that that's elastic. So if we think back a little bit, back to these diagrams, we use these slopes of these lines. We use the slopes of the lines to indicate something about elasticity. And we saw that a steep line will generally be less elastic, and a flattish line will be more elastic. But that doesn't mean the slope of the line is the elasticity. It's part of the elasticity, but it's not all of the elasticity. And what we're doing when we do point elasticity is this. We are not measuring the elasticity between 2 points. Right? We are not measuring the elasticity between 2 points on the same line. We're not measuring elasticity between 2 points on the same line. My drawing function is playing up here now. Right, we're not measuring elasticity between 2 points on the same line. We're measuring elasticity at a single point on the line. So we're not measuring between these two. We're not measuring elasticity between this change and this change. We're measuring elasticity right there if we're doing point elasticity, or if we're doing elasticity at point B, we're measuring right there at point B, but we're not doing the elasticity between those 2 points. We're measuring it at a single point on the line. So let's go down, and I've got a little illustration down the bottom here to show you what this illustration is about. Here is this, that we have the same point, right? We have the same point on a line and the point is there. However, that point is on two lines. It's on the red line. It's also on the black line. So although it's the same point, it will not have the same elasticity because the slope of the line plays into or plays a part in the elasticity. So if we think about line number one, the slope, line number one is a steeper slope, right? Line number one is a steeper slope. And so the slope here is 2, right? 12 on 6. There's the slope, right? The slope is 2. So 1 over 2 will give us a half. So then we multiply that out and we get an elasticity of a half on this line, on the steep line. But on the flat line, on the flat line, the slope of the D2, the slope of D2 is the slope here of this line equals 1/2. And so we're going to, we multiply that out. The price is the same. The price is the same in both. The quantity is the same in both, but the slope is different. And that's why we get two different measures for elasticity on the line. So this is point elasticity. So in your Playconomics, you might get asked to do the first price method, where you get asked to calculate the elasticity between this point and this point. Okay, that's possible. Or, so you might get asked to, what is the elasticity when the price changes from 4 down to 1, and the quantity changes from 4 down to up to 10. That is interval, or the first price method. On the other hand, you may get asked what is the elasticity at a given point. So if you're asked to calculate the elasticity at a given point, then you simply use the formula, right? If you're asked to calculate the elasticity at that point, then you simply you would do it. If you're doing it on this line, right? If you're doing it on that line, you'd simply say, well, that is the flat line. What's the price now? The price is 4, but the quantity is just 1. And that would change the elasticity now. That would change the elasticity at that point. So that's the difference between point elasticity and measuring the elasticity between the two intervals. As we go, so the last thing I want to do with you is look at the issue of revenue and elasticity. Generally along the line, what we will find is this, that the top of the line will tend to be elastic. In the middle of a straight line demand curve, that is where we transition from being elastic to inelastic. So at the point halfway down the curve, that is where at least elasticity goes from being more than 1 to elasticity being less than 1. And what I want you to look at here is just why this matters, right? Why this matters to the seller of a good. So I want you to think about this. What would be the revenue if we sell this good at $4? If we sell that revenue at $4 and we sell 5 goods, then at that point, at that price, revenue equals $20. Revenue equals $20. And then imagine that we lower the price. We lower the price to $3. What's our revenue now? Our revenue is the red rectangle. The revenue is now $30, right? It's $3 times 10 goods, so that's $30. So what is revenue? Revenue is simply the price multiplied by the quantity, right? It's the quantity price times the quantity. That's the revenue. So in the elastic part of the curve, in the elastic part of the curve, a fall in the price means a rise in the revenue. So if price falls, the revenue rises. That's our revenue rule. That another way that we can tell a price elastic good is that the price and revenue move in opposite directions. Now I'm going to go down to the next slide, and I'm going to go down and I'm going to illustrate at the bottom of the curve here. Let's imagine originally that the price is 2 and we're selling 15 goods. So at $2, revenue equals $30 because it's simply 2 times 15. And then imagine that we're going to lower the price. We're going to lower the price to $1. And at $1, we do sell more goods, but we sell 20 goods. We sell 20 goods. So our revenue falls from 30 to 20. So what happened here? The price went down and that's 20 at $2. Price went down from, what did the price go down from? 3 to 2. The price went down from 3 to 2, but the revenue also went down. What did it do? It went from 30 to 20. So they move in the same direction. So if we're thinking about elasticity and revenue, we say if goods are elastic, right? If goods are elastic, the price and revenue move in opposite directions. Move in opposite directions, and if it's inelastic, price and revenue move in the same direction. Okay, terrible handwriting. So those are our revenue rules. And I'm going to go back very quickly now, and I'm going to explain to you why this matters. Right? Why this matters. So I'm going to try and find a cleanish copy of this diagram. Imagine that you are running a supermarket, and at the moment you're charging P1. At the moment you're charging P1. So here you are, you're charging P1, and you're wondering whether you should lower your price, right? You're wondering whether you should lower your price. Now, should you lower your price? Well, if you lower your price, this is what's going to happen. your revenue is going to go from the red square to the black square. All right, now on the other situation, should you lower your price from Coca-Cola, you're going to go from the red rectangle to the black rectangle. Now, if you go from the red rectangle to the black rectangle, for the Panadol, right, lowering that price was a bad idea. Right, lowering the price was a bad idea because your revenue went down. Right, your revenue went down. On the other hand, what about for the Coca-Cola? Was lowering the price for the Coca-Cola a good idea? Well, look what happens to your revenue if you lower the price for Coca-Cola. Your revenue goes up. So in this case, lowering the price, that's a good idea. For the Panadol, lowering the price is a bad idea. And that explains why when you go to a supermarket, you're more likely to see the Coca-Cola on special than you are likely to see the Panadol on special, because the business knows the implication of changing its price. In the case of the Panadol, it pays the business to keep its price high, because keeping the price high, lowering the price will not gain it many more consumers. But in the case of lowering the price for Coca-Cola, lowering the price will gain it a lot of consumers, and therefore it will gain it a lot more revenue. Okay, very quickly, we're going to do the elasticity of supply here, and then I'm going to finish this part of the lecture. We're going to do the elasticity of supply. I'm going to simply draw a supply curve for you. The supply curve goes up, and if we just imagined that this was price 10 and then this is price 15, the price goes up. So we'd have a percentage change in the price, and that would be equal to 50%, right? The percentage change in price, because the change was 5 and the base is 10. So the elasticity goes from 10 to 15. So there's a 50% change in the price. And then we see that leads to a change in the quantity from 10 to 25%. 25%. So this would be a change of 15 over 10. So the percentage change in the quantity equals 15 on 10, which is 150%. So the elasticity of supply here is 3. And that's how we work out the elasticity of supply. The only difference between the elasticity of supply and the elasticity of demand in this situation, the only difference here is that with the elasticity of supply, the price went up, the quantity went up, so there's no negative sign in front of the elasticity of supply. So we could do a little bit more here, but I think because we need to move on to our next lecture topic, I'm going to finish our explanations of elasticity there. The formula basically for elasticity of supply and demand are the same. I just remind you that you can do a little bit more study on this stuff. We do have these Lightboard mini lectures. All right, we've got those Lightboard mini lectures on everything that we've done to this point: measuring elasticity, measuring point elasticity, elasticity and revenue. If you want to revise a little bit more of that in a little bit more detail, those mini lectures are available. So that ends the issue of the topic of elasticity. It is a big topic, and it will impact on the future topics that we do. What I'm going to do now is I'm going to go to our next lecture, and this is market equilibrium. So we might just take a 1 minute break here, and I'll leave the slide in front of you. I'm just going to take a 1 minute break, and then I'll be back. Start the next topic. All right, now we're starting topic 4 today, or chapter 4. This is equilibrium. Last week we did the supply curve, and we saw that slopes upward and to the right, and we saw that the demand curve slopes downward to the right. And then what we have just done yesterday and today is elasticity, and we've mostly looked at demand, and we've seen that the demand curve can slope down very steeply, which would indicate an generally inelastic demand, or it could be far flatter, and that would indicate an elastic demand. What we're going to do now is look at the two curves on the one diagram. We've looked at the two curves on separate diagrams. Now we're going to look at them on the same diagram. So I'm going to transition to that, and we'll see how far we get. We may not get all the way through this topic. We'll see how we go. Okay, so we're doing demand and supply analysis. Now, the first thing we need to do on this presentation is to think about the difference between individual demand and market demand. So I want you to imagine that we've got just two consumers in the market, right? We've got two consumers in the market. Our two consumers are Jack and Jill. All right, Jack and Jill. And they have two different demand curves, right? They have two different supply curves. They have two different supply curves. So, for example, Jack, at the price of $1, he will only supply one good, whereas at the price of $1, Jill will supply two goods. So already I can see that that Jill's supply curve is more elastic, right? Jill's supply curve is more elastic, and it probably indicates that Jill is a more efficient producer because she can provide more goods than Jack does at the same price. But then over on the right-hand side, we have the total market supply. Now, in a real market, of course, the market supply will not be made up of two suppliers. Well, generally it won't be. In a big market, if you think about the market for fruit or apples or beef or anything like that, of course there are thousands of suppliers. But when we get to the market supply, these two, we could call them T.O. or Ty as well, of course, but anyway, I've called them Jack and Jill. I want you to think about how many does Jack supply at $1? Jack supplies one good. How many does Jill supply at $1? Two goods. So if we put them two together, Jack and Jill, right? Jack plus Jill, or if you like, T.O. plus Ty, 2 plus 1 is 3. So that is our market supply. And then if we think about the supply that Jack supplies at $2, Jack supplies 2 goods, Jill supplies 4 goods, so 2 plus 4 is 6, and so that's our market supply. So our market supply is the sum of individual supplies, and all we are doing is we say we're adding horizontally. Why are we adding horizontally? Because if I take the price of 2, I'm adding that 2 to this 4, right? I'm adding 2 to 4, and I get 6. That's what we mean when we say adding horizontally. So what we have to remember here is that the market supply is generally not done by a single supplier. It's usually done by a number of suppliers, and particularly if we're assuming perfect competition. Perfect competition, as we saw before, imagines that everyone in the market is a small player. Next, the same goes with demand, right? We have ISA, right? We have ISA and we have Ting. So what can we assume from this? What I'm assuming from this is that Ting either likes this product more, right? Ting likes this product more or has more money, because at $4, it's not letting me draw now. I'll try a different colour. At $4, ISA can only consume one good, but Ting can consume 2 goods. So we've got 1 plus 2. 1 plus 2 gives us 3. And then at $2, they're both demanding the law of, they're both showing the law of supply. Here at $2, ISA is consuming 2 goods, and Ting is consuming 4 goods. So the total market demand is 6. So we have the demand curve. Again, the aggregate demand curve, we're just adding horizontally. At price 2, we're just adding the horizontal for ISA, and we're adding the horizontal for Ting, and we get the horizontal for the market. So in a perfect competition situation, the market supply is the total of the individual suppliers. So the aggregate demand or supply is the total, represents the horizontal sum of the individual supply and demand curves. Right? So 2 key words, sum of the individuals. That's what we mean by the market supply. How much gets traded and at what market price? So So that's what the market determines, really, right? At the market equilibrium, there will be a price. So at the market equilibrium, we calculate how much gets traded and how much is bought and how much is sold. So the quantity demanded will equal the quantity supplied at the equilibrium. That's where the word equal comes from. These two will be equal, but they'll only be equal at the equilibrium price. Not at any price, just at the equilibrium price. At one price, they will be equal. So we can see this on the next diagram. Excess demand. If there's excess demand and excess supply, this indicates a situation where the quantity supplied is larger than the quantity demanded. And what that indicates is this, that the price in the market is above the equilibrium price. The price is above the equilibrium price, and over a period of time, the price in the market cannot stay above the equilibrium price. The price will move to the equilibrium price. We have excess demand. Excess demand indicates that the quantity demanded is larger than the quantity supplied. What that indicates is this: the price that exists in the market is below the equilibrium price. And in both cases, excess demand and excess supply will not exist for long, because the market will eventually move itself. No one moves it, but the market moves itself to the equilibrium price. And I'm going to show you how that happens. Now, we have a lot of slides to illustrate this. I'm going to flick through all the slides that we have to show it, but I think I can show it a little bit quicker. So I'm just going to go back here. First of all, right, we have this slide in front of us. So first of all, how do we know where the equilibrium price is? Well, I can label the equilibrium price. That's very easy to find. I'm putting a dot there. It's where, what did we say about the market demand and market supply? This is the quantity axis. Here's the supply curve. Here's the demand curve. So only there is the quantity demanded equal to the quantity supplied. If I go above that market equilibrium, if I go up here, then now the price is not at the equilibrium, right? The price is above the equilibrium price. And what does this mean? It means that a high price is good for suppliers, because if you're selling a good, you want a high price. But if you're buying a good, you don't want a high price. So if the price is above the equilibrium price, the quantity supplied will be above the quantity being demanded, and so there is an excess supply. This is no good for anybody, because the suppliers are making a lot of goods which they can't sell to the demanders. And so it's not good for the suppliers, and it's not good for the demanders either, because the price is too high for them, and they are buying less goods than they would at the equilibrium point. So if the price is above the equilibrium price, then we have a situation of excess supply. And so in this case, right, this is called disequilibrium. All right, this is disequilibrium. And what does disequilibrium mean? Disequilibrium means that the quantity supplied does not equal the quantity demanded. right? The quantity supplied does not equal the quantity demanded. So I'm going to just clean that diagram up. I think I can do it this way, actually. Might be easier to use the eraser. Okay, now what about all right, my diagram is pretty clean. Now, what about then if we look at the price below, right? The equilibrium, the price is now below the equilibrium price. Here it is. It's down below the equilibrium. Of course, suppliers don't like this low price because there's no money in the product for them. When they sell the product, there's not enough money there. So there's not many suppliers involved. On the other hand, the demanders want to buy a lot of product. So this many demanders want to buy the product, but they can't get the product because the quantity supplied is much lower. So that's the situation when we have excess demand. Now, what is going to happen here is that we have a whole lot of sellers. We have a whole lot of sellers and a whole lot of buyers, and each of them has a different reservation price. So let's think about what's going to happen if the price was at 2. Right? What's going to happen if the price was at 2? If I make up a number here, right? If I make up a number, I'm going to imagine that the number there is 6. And I'm going to imagine that the number here is 1. So now I've got one buyer and 6 sellers. So our excess supply is 5. So these 5 sellers cannot sell their good. What are they going to do? Well, what's going to happen is there's going to be competition between these sellers, and these suppliers, they will lower the price. They will lower the price. They'll say, we can't sell the product at 2. No one's buying it at 2. So as they lower the price, what happens? They lower the price a little bit, right? They lower the price a little bit, and one seller drops out. Right, now there's only 5 sellers, but because they lowered the price a little bit, one buyer drops in, all right, and then they lower the price again, right? They lower the price again. They'll eventually lower the price down here. As they lower the price, more sellers drop out. So now I'm going to change that number to 3. More sellers drop out, and more buyers drop in, because the price is more attractive. So the quantity demanded goes up, the quantity supplied goes down until the 2 are equal. Once you get to 3, there's nothing to make the price change. But while there's an excess supply, there's pressure to lower the price. So that's how the market reaches the equilibrium. That in the case of excess supply, competition among the sellers causes the price to fall. Okay, so the equilibrium price represents the price. It represents the price where the quantity supplied and the quantity demanded are the same. That's what the equilibrium price means. And I'll just say this here, right? It equals the price, and the market equilibrium, right? Market equilibrium is arrived at by market forces. If the price is too high, market forces will lower the price because the firms are forced to lower their price in order to try and sell their product. So what we saw in our curve, the curve we just saw, was a whole lot of demanders and suppliers. We'll see if we can get a clean copy of that diagram. This is kind of clean. All the way along this line, all the way along our supply curve, there are a number of different suppliers. I think we said there was 6 different suppliers. Now, supplier number 6 will only sell the good if the price is 2. Supplier number 5 will sell the good at a lower price. Supplier number 4 will sell the good at a lower price. So this is what we mean by the reservation prices. So the reservation price is this. It's of the buyer, right, of the buyer. It's the highest price the buyer is willing to pay, right? The higher the price that the buyer is willing to pay. The reservation price is the lowest price the seller is willing to accept. Now, sellers like high prices, but we have to say, well, what's the lowest price you'll sell for if you're the seller? And if you're the buyer, of course, the buyer would like low prices, but we ask the question, well, what's the highest price they would pay if they had to? So that's what we mean by the reservation price. So we've got a number of buyers and sellers here. Buyer number one has a higher reservation price. Buyer number 1 has a reservation price of 6. Buyer number 2 has a reservation price of 5. Buyer number 3 has a reservation price of 4. And buyer number 4 has a reservation price of, there is no buyer. There is no buyer at 4. Buyer number. This is 1, 2, 3, 4, 5. In the end, what we're going to find here is that the market will reach the equilibrium price at 3, and the quantity will be 3. The price is 3, and the price is 3 and the quantity will be 3. So I'll just take this line out here, right? The price is 3. I'll put it in a bit more neatly. Price is 3, and this is our equilibrium. That's where the 2 lines cross. So I want to talk to you then about this issue of reservation prices. We could see on our previous diagram there that there were a number of different buyers. One buyer had a reservation price of 6. One has a reservation price of 5. The next one had a reservation price, I remember, of 3. Then the fourth one has a reservation price of 2. And the last one had a reservation price of 1. So what does a reservation price mean? I want you to think about lining up for coffee in a coffee shop. And there's a queue of people lining up for the coffee. The price of coffee might be $4.50. Let's imagine. The price is $4.50. But in that line, there are all sorts of people on all sorts of income, right? They've got all sorts of income. And secondly, they've got all different levels of desire for coffee. So for some people, even though the coffee is $4.50, if they had to pay $10, they would pay it, because either they don't care about the money because they've got plenty of money, or because they've got a mad craving for coffee and that coffee gives them a lot of utility. So some people in that line will have a very high reservation price. But that doesn't mean that if they've got a reservation price of $10, that they're going to pay $10. If the price of coffee is $4.50, then they're paying $4.50. So we've got a price up here, which they would pay if they had to, and a price down here, which they actually do pay. So for someone with a reservation price up here at $10, they're actually getting the product cheap because they're saying, I would pay this, I am paying this, so that is we call that their consumer surplus. Now, that person in the coffee queue may never have heard of consumer surplus, and that's not the way they express consumer surplus, but they might just express it this way by just buying the coffee without thinking very much about the price at all, right? It's not a bother to them, and they're getting their coffee. So we regard that as consumer surplus. At the same time, there may be many coffee shop owners in the street. The general price of coffee is $4.50, but some of those producers may actually be able to supply it if they had to at $2. So they could supply it at $2, but the general price is $4.50. So they're going to be charging $4.50 because that's what the market price is. And they have what we call a producer surplus because they would sell the product at this price, but they're actually getting this price. So they're getting more than they really would accept if they had to accept a lower price. So that's their producer surplus. And again, they may never have heard the word producer surplus. I doubt that most coffee shop owners have heard the word producer surplus. But you'll have a producer surplus if you're happy enough with the price you can get and you're easily covering your costs, so your marginal cost. So that's what we mean when we say consumer and producer surplus. So we'll go back here, we'll go back to our slides, and then we're going to get into the area of calculating our consumer surplus. So I want you to think about now consumer number one. Here we are, consumer number one. They would buy the product at $6, but the price is $3. So their consumer surplus is $3. Their consumer surplus is $3. Their consumer surplus is $3. Let's think about buyer number two. Their consumer surplus is the difference between 5 and 3. They would pay 5 if they had to. They're only paying 3. So their consumer surplus is 2. So we've got 3 plus 2. And then buyer number 3. Buyer number 3 has no consumer surplus because their reservation price is 3 and they're paying 3. What's that person thinking about this coffee that they're buying? They're thinking, well, it's expensive for me, but I'm buying it. But if it gets any more expensive, I'm not buying it. So that's consumer number 3. Now, what about consumer number 4? Consumer number 4 has a reservation price below the equilibrium price. So consumer number 4 and consumer number 5, they are not buying coffee at all, right? They're not buying coffee at all. It's not that they don't want coffee, but they're not buying it at that price. Buyer number 5 would only buy it if the coffee was $1. Now then, think about the producer surplus. Producer number 1 would produce for $1, but actually gets $3, so their producer surplus is 2. Producer number 2 would sell for $2, but the price is actually 3. So I could say the producer surplus here is equal to 3, 2 plus 1, and the consumer surplus in this situation is 3 plus 2. That's 5. So the total surplus is equal to 8. The total surplus in the market is equal to 8. And I could colour this in. I could colour this in. I could say here's our equilibrium price. I could draw that, and then I could draw this, and I could shade all that in, and that represents our consumer surplus. I could also do this. I could say this represents my producer surplus in there, so I can shade those areas in. So the consumer or producer surplus exists where your reservation price is different to the actual market price. So consumer surplus, what's it actually represent? It represents the difference between what the consumer pays and what they are willing to pay. The producer surplus is the difference. So it's the difference between the price that it receives and what they would be willing to receive under the worst possible circumstances. So this is the concept of consumer and producer surplus. So we've just got slides that illustrate what I just did there. So I'm going to go through those, I'm going to keep moving on. So the slides on the slide presentation, there's a few more slides than we need to actually illustrate the point. So I'm going through these slides fairly quickly. The total surplus, right? The total surplus, we looked at the total surplus, right? The total surplus, what was it? A total consumer surplus is the total of all the consumers. So what does that mean? It means consumer 1 and consumer 2, not consumer 3 because there is no surplus. What's the producer surplus? The producer surplus, the total of all the producers that get a surplus. So that's the producer surplus, the total of all the producers. And then the total surplus, of course, is the two together, right? The total surplus is simply the red plus the black. Whoops, the red plus the black, right? That's the total surplus, the consumer and the producer, right? That will be the total surplus. Moving down, so you can see the diagram there that I've previously shaded. In a perfectly competitive market, total surplus is maximized. Total surplus is maximized at exactly the equilibrium price. I'm going to see what the next slide is. Okay, let's go to the next slide, and then I'm going to get this slide and I'm going to copy it. Okay, we've got a couple of copies of this slide now. First of all, in the previous lectures, we've seen that in a market with many demanders and many suppliers, our lines become straight lines because we have maybe thousands of people, each with a slightly different reservation price. So we're not talking about consumer number 1 and consumer number 2 and consumer number 3. If you think about this number being, say, 10,000, then it becomes impossible for me to say, well, what's the difference between consumer number 7,000 and consumer number 7,001? I can't do it. So the lines simply become a straight line. And we say that the consumer surplus will be maximized at the equilibrium. Why will it be maximized at the equilibrium? Well, I want you to imagine that the price is not at the equilibrium. What if the price is above the equilibrium? That means that the quantity being demanded is equal to QD. It means that only QD is being bought. It means that these goods are not being bought. These goods are not being bought, they are not being sold because the demanders are only buying QD. So that means the sellers are only selling QD. So these consumers that I'm shading, they are not buying the product. They're missing out on the product. So we call that lost surplus. This area in here is lost surplus. This consumer that I'm indicating here, they had the opportunity of buying the good at the equilibrium price. They would have had a higher reservation price. They would have had a consumer surplus in there, but they don't have it. And likewise, this consumer, the producer down here, he would have been willing to sell the good at the equilibrium price, and they could have had a consumer surplus. But for these goods, right, there is no production, there is no consumption. In other words, people are just missing out on the good. The businesses are missing out on producing the good, and the sellers, the buyers are missing out on buying the goods. So we might say, why would the price ever be there? Why would the price be there instead of the equilibrium? And I'm going to give you one example, e.g., what if the government says it has to be there? What if the government makes a rule and says we're going to put in a minimum price? Government minimum price. Now, why would the government do that? The government might do that because they have a good intention. They think they are protecting the supplier. They're trying to get a good deal for the supplier. They're saying if we put the price up there, the suppliers will love the higher price. They can produce a much greater quantity. But the only problem is that's not going to work unless the people buy the goods. So it might be done for good intention, but it may not work. On the other hand, the reverse could happen. What if the government says, well, why don't we put a price floor in there? A price ceiling in there. Why don't we put a maximum price? Well, the problem with that is suppliers will only make this amount, and although the buyers might like to buy this amount, they can't do it. And the market is not going to be at equilibrium anymore, which means the suppliers are not going to make the goods that I'm marking in red, and that means the buyers can't buy those goods, so the buyers miss out on their opportunity to buy and enjoy a consumer surplus, and the producers miss out on producing the good. So that is an example of lost surplus. So that is why we say that the market will maximize the surplus at the equilibrium. The market will maximize the surplus at the equilibrium. I'll just show you one other aspect of this. I'll clean this up and I'll show you one other aspect of this. What would be wrong in producing out here, right? What would be wrong with that? Well, what's wrong with that is that if I think about the equilibrium there, and we think about this quantity here, what are we to make of these goods here between Q, right, and QE? What about those goods? Well, what this indicates is this, that, whoops, there's a bad labeling there, right? That's supply equals demand. These are the textbook slides. They're not my slides. But anyway, there's a mistake there. Now, what's wrong with that? Well, what this means is that this is the supply, right? That's the marginal cost, right? That's the marginal cost of making the good. And it's the supplier's reservation price, right? It's the supplier's reservation price. And down here, this is the marginal benefit, and this is the demander's reservation price. There's a demander's reservation price. And you can see that the marginal cost of making the good, is greater than the marginal benefit the good gives us. In other words, these goods, they cost more to make than they deliver in satisfaction. And what we would be better doing with these goods is getting the resources that make these goods and making some other good. So these goods are not, this production is not good, right? This production is not good because the cost of making the good is greater than the benefit. So that is why we say E is the most efficient point, the equilibrium, because all the way out there, every good made out to that point gives a greater marginal benefit than it does a marginal cost. So that is another reason why we would say that the equilibrium is the most efficient point. That's the one that gives most satisfaction in the market and the level of greatest consumer and producer surplus. And if we then acknowledge that E is the most efficient point, we could go beyond that and say, well, any government policy, for example, that moves us from E is not necessarily a good idea. Okay, now we're going to explore changes in equilibrium. So again, this is the textbook labelling. I don't know that we need the word clever or toy in here. But what I want you to look at here is changes in equilibrium. So I want you to imagine here that we start at an equilibrium point. We start at an equilibrium point at Q and P. That's our original equilibrium point. What sort of product are we talking about here, right? So I want to think about something like the market for gas and gas for heating, right? So we're thinking about, all right, we've got the gas market, and then what we get is in Europe, Russia, Ukraine, Germany, etc., we get a very cold winter. We get a very cold winter in Europe. What do people do? They turn on their heaters. That's what they do. And when they turn their heaters on, many of those heaters will be using gas. So the demand for gas increases. The demand for gas increases. Why is the demand for gas increased? Because people need more gas in their heaters. So that moves the demand curve to the right. As the demand curve moves to the right, if we think about the original price, instead of the quantity being demanded at Q, now the quantity being demanded is over here where I'm making the dot. In other words, there's an increase in the demand, and that increase, the demand is increased, and as a result of that demand increasing, the price will rise. So the price rises, and when the price rises, gas suppliers say, well, that's good, there's a higher price for gas, we are going to expand our supply for gas, and more gas will be supplied, and so the equilibrium will move to E1. It'll move to E1. The price will be higher and the quantity will be higher. And we would call this, what we've just done. I'm going to give that a name. I would say, in terms of economic speak, that is an increase in demand, right? It's an increase in demand. Why did it increase? It didn't increase because the price increased, right? It increased because of a non-price factor. And in that case, the example I just gave you, the non-price factor, e.g., was the cold, right? The cold and therefore the cold winter, right? The cold winter. So that was a non-price factor, right, in the gas market. Now, how would we describe this movement along the supply curve? That supply curve didn't move, but there is a bigger supply. So we call this a rise in the quantity supplied. Why did the quantity supplied rise? Because it responds, this is a response to a rise in the price. So the demand is moving because of the cold winter. The supply is responding to the price rise. And we've got two different terminologies. We've got two different occurrences on the diagram. One curve is shifting, and there's a movement along the other curve. Okay, so here's another example, right? This is a shifting in supply. So let me, right, e.g., better technology. All right, better tech in making. I think this is what is actually happening, right? E-vehicles, right? Electronic vehicles, right? E-cars. So over time, the technology for making electronic cars is getting better. So as a result of that, supply conditions increase, and so there's an increase in supply because the car makers, firms like BYD, would be saying things like this: at this price, we used to be able to make that many, but at this same price, now we can make this many. So our curve moves to the right. And as a result of the curve moving to the right, they start making more cars. They start making more cars. As they start making more cars, the price falls. And as the price falls, people buy more electronic vehicles. So what have we got here? Right, what we've got is an increase in supply. We've got an increase in supply and a rise in the quantity demanded. What made the supply rise? Wasn't the price, right? It might have been the price of resources, but not the price of the vehicle. So there was an increase in supply that caused the price to fall, and the demanders are responding to the lower price. So we've got two different types of, we've got a couple of different things going on there. Okay. Now, let's imagine that we've got two demand curves, and we start we've got two demand curves here. We might have a couple of shifts going on here. So we're going to start at the original equilibrium. So the original equilibrium is going to be the intersection of the original supply curve and the original demand curve. So that's the original equilibrium there. All right, there's the original equilibrium. And then we see that both the demand curve moves out, the demand curve shifts out. So there's the shift in demand. And we can see also that the supply curve is going to shift out. I'll put an arrow up there. Now, in both of those cases, right, the demand curve and the supply curve have both moved to the right. They've both moved to the right. So supply and demand both increase. So I could say, what's going to happen to the quantity here? Right? What's going to happen to the quantity? Well, if the new demand curve, if here's my new demand curve, intersects with S1, right, the new equilibrium will be out where I'm making the black mark. And what could I say there? I could say, well, at E1, or at E1, I'll call it E1, at E1, the price, the quantity has gone up and the price has gone up. Here's the price going up. The quantity has gone up and the price has gone up. On the other hand, what if the shift in the supply curve is not S1 but S2? S2. What's going on at S2? Here's the equilibrium quantity here. The quantity, so at E2, the quantity has gone up, but the price has actually gone down, right? Here's our equilibrium here. So when we are playing with these models, you will get questions like this, right? You will get questions like this, where you will be told, I'll clean this up. I'll clean the diagram up for you. I'm cleaning this up. You will be told that there's an increase in demand and an increase in supply, and then you will be asked questions like this. Right, what happens? You'll be asked questions like this. Question A, or option A. What happens to the quantity? Right, what happens to the quantity and what happens to the price? So I could say, well, certainly the quantity will go up, but with the price, if I'm just told that both these curves move to the right, I'm told both those curves to the right, the quantity will go up, but I'm not sure what's going to happen to the price, because it really depends how much the supply curve shifts. So I can be certain of that, right? I can be certain of that, but I cannot be certain of what's happening to the price. I was going to frame a multiple choice question. I won't do that here, right? I'm just showing the principle here, that where we get two curves moving, we can usually be certain about one of them, but not the other. We can usually be sure about which way one moves, but not the other one. All right, Pareto efficiency. Very quickly, I'm going to go through this term quickly. It's 11:45. I am going to go to the end today, right till, well, pretty much to 12 o'clock. Pareto efficiency essentially means that any situation in which it is impossible to make one individual better off without making another person worse off. So that's what we mean by Pareto efficiency. With the way we define it is where the total surplus is maximized. Where the total surplus is maximized. So we'll examine this concept of Pareto efficiency a bit more next week. But let me just explain to you what we really mean by Pareto efficiency. In a market, we have a demand curve and a supply curve, and we've got an equilibrium, and this equilibrium point is the point of Pareto efficiency. And what that means is that at that point, Pareto efficiency might happen if we give something to the supplier and take something from the demander. If those two things were equal, we would still have Pareto efficiency. But the problem is, in the real world, it's very difficult to do that. So for the moment, let's just identify Pareto efficiency at the point of equilibrium, and we'll explore that in a bit more detail when we get into government intervention next week. So a Pareto efficiency transaction is one where all parties involved are better off. Let me show you a Pareto efficiency transaction. Let's imagine that for some reason, we have a price ceiling in the market. If we have a price ceiling in the market, then our output is here. Our output is there. The area of consumer surplus is up here. The area of producer surplus is down here, in there. But the area of lost surplus is in there, right? So if we have a price ceiling where the government is limiting the price, the market is not operating at efficiency. So what is a Pareto improving transaction? Where all parties are better off. In other words, where the government gets rid of the price ceiling and the price returns to the equilibrium level, and now the consumer surplus is up here and the producer surplus is down here, and there is no lost surplus, right? There's no lost surplus. That's what we mean by Pareto. That's an example of a Pareto improving transaction. In other words, a Pareto efficiency transaction moves towards equilibrium, right? It moves towards the equilibrium. All right, we're going to look at now the invisible, what we call the invisible hand. The invisible hand principle. I'm just looking at this. Okay. We're going to start with this idea of society well-being. And we're asking the question, do markets help society's general level of well-being? And essentially, society's well-being will be improved if we become more efficient, and if we're more efficient in the way we use our resources and maximize our opportunities. And from this topic we're doing today, we're assuming that markets bring us towards this point. Now remember, we're talking about a particular type of market. We're talking about perfect competition. Perfect competition. In other words, where there are many, many suppliers and where there are many, many demanders. We are not talking about monopolies or oligopolies here. We're talking about markets in which there are a large number of very small scale producers and a large number of consumers. And when we're talking about this, we say there's an invisible hand. What's the invisible hand mean? It means that no one is moving the market, right? The market moves itself. The market moves itself. In other words, government is not telling people what to buy. It's not telling people what to price to pay or what to charge. It's letting all the individuals in the market work for their own benefits. And the theory is, remember this is theory, and whether theory actually plays out in reality, we could argue about that. But if individuals are making individual efforts, that will also be generally good for society. Generally, not always. But that's what the invisible hand means. It means no one is in control, right? It means that governments are not allocating resources in the market or controlling prices or controlling output. They're letting the market deal with its own issues. And so we assume then that firms in a perfect competition will always move to the lowest possible price. Firms in a perfect competition, right? So we're talking about competitive market. I'm underlining that word, competitive markets. We assume that the price will always be at the minimum possible. So I want to draw a diagram. I'm going to draw it myself. Here's the way that we visualize the market. I have in the market many demanders and many suppliers, and this is the market for a product. Let's say this is the market for apples, let's say. And the market price will be there, right? The market price, the equilibrium market price is there. Now, then, when we have individual firms in the market, those firms do not have a choice about price. Those firms do not have a choice about price. They will all be forced to charge the same price. They will all be forced to charge the same price, because if anyone tries to charge more than that price, then other firms will simply charge less than them. So if a firm tries to charge up here where I'm making the dot, no one will buy from that firm because all the firms are charging the equilibrium price. And then through this, we put the average cost curve. There is our average cost curve. And you can see that the average cost between where I'm making the first red dot and the second red dot, the average cost is below the price. So between where I'm making the two strokes on the bottom of the quantity axis, anywhere between there, if the firm makes anywhere between there, the firm will make a profit. But where exactly will the firm make the maximum profit? Well, for that, we need the marginal cost curve. And for reasons I'm not going to explain, the marginal cost curve crosses the average cost curve at the minimum. From there, we say, where does the firm produce? Right? Where does the firm produce? What quantity is the firm going to produce? Well, the answer is the firm is going to produce where the price is enough to cover the marginal cost. So the firm will produce here, and I'm going to call that Q maximum profit. That's the maximum profit for the firm. And how much money is the firm making? Well, the firm is making the difference between the price and the average cost. So that's the profit that the firm is making on each good. And then I'm going to shade that by the number of goods. So let's imagine that this number was 100 goods. Imagine that this is $3, and imagine that the price is $5. Then the profit would be this. The profit would be $2 profit on each good times 100 goods, and that would equal $200 of profit. That's $200 of profit. So that's how firms establish their that's how firms know what they are making. Now, if we then come down to the next thing, right, or go back here, if firms are making a profit, I think I'll just keep going here on this same diagram. If firms are making a profit, If firms are making a profit, I want you to think about what's going to happen next. This profit profit here, this attracts new firms. And so over a period of time, because this profit exists, new firms are going to enter the market. So firms will enter the market, and they are going to enter the market. And because they enter the market, there's more suppliers and the price drops, the price falls. So that in the long run, firms enter the market and profits disappear. So that in the long run, the price will eventually settle where the supply in the market gives a price that allows the firm to just make a normal profit. The price eventually comes down to where the firm just makes zero economic profit. So we call this the long run equilibrium. The long run equilibrium. And what we're supposed to get from this is that if firms are making big profits, the supply curve will eventually move around in such a way that firms will not make any more than economic profit. I'm going to talk to you about this as we sign off. The example that I will give you here is about Uber drivers. Okay, now Uber drivers exist in a market like perfect competition because there are many suppliers and they supply pretty much an identical good. I know that the cars look a bit different, but an Uber ride is an Uber ride. And if Uber drivers are making more money than people in similar occupations that Uber drivers could do, working in a bar, working in a shop, something like that, right? That's their alternative occupation. If Uber drivers were making more money than those other occupations, people in those other occupations would see the big money that the Uber drivers were making, and that what they would appreciate is that it's pretty easy to become an Uber driver. There's a low barrier to entry, and they could see that there's more money in that occupation. And so the Uber drivers might be making more money at the moment, but workers from other occupations who could easily transition into Uber driving would do it. So suddenly, because as a response to them making more money than similar sort of semi-skilled jobs, more people enter that business. There's now more Uber drivers. It's harder to get fares, and therefore there's less surge periods, and the Uber drivers' income would start to fall so that there's less and less difference between their earnings and similar occupations. And that's really the description of the way perfect competition works, that because people can easily enter an area of perfect competition, when people in that business start to make serious money, other people will enter that business and the profits will disappear. And in the end, the level of economic profit, which is the difference between what you earn and what your opportunity cost, that difference will disappear and you will be earning the same in Uber driving as you would in comparative occupations. That's the way, that's the theory of perfect competition. In other words, you want to be really wealthy, don't enter an area of perfect competition, because when you start to earn serious money, other people will enter that business and they will compete your profits away. That's the way we assume perfect competition works in the long run. And that's why we say it's efficient, because it brings prices down to the minimum that they can possibly be. So we've actually finished where we're supposed to be up to now. We've finished equilibrium. We might tidy a little bit up at the start of the next lecture, but we're back on schedule. And so thanks for your attention, and I will see you all next week.